Hi, everyone. Thank you so much for coming on a Friday afternoon of KubeCon. I know people are thinking about going home, so thank you for coming in here. I am going to give you an introduction to kops and an update on the project. We're going to start from nothing and then go through some of the internals and a little bit of the roadmap. So if you're more advanced, apologize for the beginning. If you're more of a beginner, I apologize for some of the stuff at the end. I wanted to just give you I wanted to start with a very quick idea of, if you haven't seen it, what is the kops experience? So if we want to create a cluster, you do kops create cluster, the name of the cluster, and the zones in which you want to do it. So US East 1B, and this will create a cluster in Amazon's US East 1B, although I actually recently joined Google, so even bigger. You got it. Bigger. View bigger. View bigger. Better? Yes. Okay. I actually recently joined Google, so I realized that I probably should be creating it not. Let's do. I'm going to get to the top of the screen again. Not in the Amazon US East 1B, but in Google's US East 1-B. So that will create it in Google instead of in Amazon. And actually, if we're going to do that, let's have some fun and do a. Oh, there it was. So we are going to do an HA cluster with master count 3 and in zones US East 1B, US East 1C, and US East 1D. So we will start that going, and then we'll get into the talk, and we'll come back in a couple of minutes, and hopefully, fingers crossed, everything will be working. So you can see it's thinking about it. That line there says that it detected that the cloud was GCE based on the zone we specified, and now what it's doing is it's basically building a model similar to how Terraform works, and you can see all the tasks, is what we call them, that it's going to create. So a bunch of key pairs, some instance templates for GCE, some instance group managers, which are like auto-scaling groups on AWS, some firewall rules. Anyway, a whole bunch of stuff. And we can now do update cluster. Yes. It's actually going create. Pardon me. What do I do? Test. Kops update cluster test.k. The name of our cluster. It's actually going create it in the cloud. And before it was just saying what it would do. Think. And it's going to run those, I think it was 60-odd tasks that it had to run. That's issuing some certificates. The internet is a little bit slow. I apologize for that. Well, we can leave that running, and we'll come back to that in a second. I'm pretty sure it's going to succeed once the internet is happy. So, overview of what the talk's going to be, quick introduction to kops and a demo, a little bit about some more advanced usage of kops, using it with Terraform when you might want to do that, how you can use a more declarative way of managing your kops clusters or the kops objects. A little bit of an overview of how the project is doing on GitHub, and in general how our project is doing. A little bit of understanding how it works under the hood, so if something does go wrong, you have some idea of what to do, and sort of the vision for kops for the next, I guess, 1 to 2 years, what the big areas are. So we looked at the UX around creation. You create a cluster that essentially is, the kops CLI tool is supposed to feel a lot like kubectl. So when you kubectl create secret, for example, that's a sort of facade, or that's sugar on top of creating an API object or a set of API objects. And kops create cluster is sugar on top of creating our API objects. So a cluster and a set of instance groups is what we call them. The cluster being the general configuration, and a set of instance groups being an instance group manages a set of instances. So we have, for example, in an HA cluster configuration, we have 3 instance groups, 1 for a master in each zone, and then 1 instance group for the nodes. And you could add different instance groups for nodes that have GPUs, things like that. So kops create cluster, kops update cluster, which actually goes and does the actual creation of the objects. This is a little bit not like Kubernetes in that because these resources cost money, unlike most Kubernetes resources, we don't immediately create them. And then in a couple of minutes, you were able to use kubectl. So kubectl create -f my application. So that's all that's required to create a cluster. The UX for upgrades is also pretty similar. So we do have some sort of guided upgrades. You would type kops upgrade cluster, and it can recommend if there's a new version of kops in the stable channel that you're using. And then you would type kops update cluster yes again. And we have another command, kops rolling update cluster yes. And what rolling update does is it makes sure that all those changes are actually immediately applied. So kops update cluster changes the desired configuration, but doesn't immediately restart all your instances, which is probably what you want. And then kops rolling update is a nice sort of staggered rolling update of each of your instances. So if you're running HA master, or even if you're running not HA master, you shouldn't actually notice any application downtime. If you're running HA master, you shouldn't even notice any master downtime. Why don't we go and see, let's see how we're doing. Wow. Oh, yep, cool. There was scrolling problems. So yes, so in the background, while I was blabbering on, we finished the kops update cluster command. So we went and created a bunch of instances, I suspect. So we should have created 3 masters and 2 nodes. Yay. 3 masters, they're interleaved, and then the 2 nodes in the middle. And if we're really lucky, this may be a little too fast, but we'll see. Hasn't got there yet. Oh, yes, it has. OK, well, we actually just hit it. Our 3 masters have joined the cluster, but our nodes have not yet joined the cluster. So we'll come back to that in another minute. But I wanted to show you what should we look at first? Let's look at let's get the upgrade scenario a little bit. So if you wanted to change, so again, a lot like kubectl, kubectl edit would be the way you would interact with these objects. So kops get cluster will list it's like kubectl get objects. You can see the cluster we created there. Kops edit cluster is the equivalent of kubectl edit cluster. Here is the YAML object for the cluster. And you can see that we're running 1.9 something. And we might want to change that, for example, to 1.4. Sorry, you can't see because of my cursor. We might want to change that to 1.9.4. And then we would save it. We would do a kops update and a kops rolling update there. And that would be all that would be required to update from 1.9.3 to 1.9.4, for example. What we just did was the equivalent of kubectl edit on a deployment, which isn't, it works great in Kubernetes, but it isn't necessarily the way that we recommend most people manage their clusters. So a better way to manage it is, out of order, a better way to manage it is sort of the declarative way of managing your cluster, where some people call it GetUps. You store all your YAML files in Git, and then you make changes in that Git repository through your normal PR process. And you'd go through, you review those changes to your infrastructure, you sign off on them, you merge them, and then a CI or CD system would apply those changes for you. So if we look at what, for example, kops get cluster, YAML does, kops get cluster will dump the full state of, actually, I think I mean kops get test.k8s.local. This dumps the full YAML for all the objects in your cluster. So there we are. We see a bunch of instance groups and our cluster spec at the top. If I pipe that to my cluster.yaml, then I can save that. And now if I, for example, the way we would normally do an update in a sort of more production environment, if I wanted to go from 1.9.4 to 1.9.5, I would edit that. I would git add, I would git commit, I would put it through the PR process. And then the CI system would run a kops replace -f my cluster.yaml, which basically takes those changes and merges them in, sort of like a kubectl apply type logic. So we have very quickly covered a lot right there. I don't know if I've lost everyone. I'm sorry if I have. But what we've seen right there is we have kops that creates API objects that should feel a lot like interacting with kubectl. You're able to create clusters on your infrastructure, be it AWS or GCE, very quickly. You can use kops edit, which is a bit like kubectl edit, to do interactive changes to your cluster. And we have a workflow that's designed for integrating into GetUps or more sort of structured environments. So that's if you wanted to have an SRE type review the changes to your cluster before you made them. Some environments are even more locked down because this is sort of a black box. And when I run kops update, we'll show you my kops update cluster. So we'll show you some of the changes that are going to happen here. Or we'll show you the changes that are going to happen here as we see them. Thinking. So there we are. So you can see that we're going from 193 is the last one we actually applied, going to 195. And you can see that, for example, the instance templates, which control the configuration of those instance groups, has changed. And you can see that the instance group managers, which is the actual groups of those instances, is pointing from the old one to the new configuration. But it's sort of, this isn't necessarily what you want to, the easiest way to understand and be sure that the kops is doing exactly what you want. So if you want to sort of peek inside the black box and understand what's going on, this is where Terraform management comes in. So we can run this command, kops update cluster target Terraform. And what this does is it actually generates Terraform output so that you can actually, if you're familiar with Terraform, you can go and look at the full Terraform output that will be created on your cluster. And
is it using Terraform internally?
It is not using Terraform internally. So we're using our own separate implementation of tasks, is what we call the things. And then each task is able to either render directly via the APIs, or render to Terraform, or render to CloudFormation on AWS. The reason we didn't use Terraform initially was because at the start, Terraform had the TF, or still has the TF state file, and it also was not as good at importing existing resources. So one of the things here is that we don't have as strong a requirement around like maintaining a TF state file. It's more similar to Kubernetes in that regard. And so it says here, Terraform output has been placed into out Terraform, and if we find out, you can see that here we have a pretty big Terraform template with the same resources right there. So as this change, as your configuration changes, you can choose to output to Terraform and get the changes, which a lot of, I guess, more ops or more controlled environments really like. One of the best way to use this is to put this into a TF module, and we have some output variables which, well, particularly on AWS, it's more important to output things like the subnet IDs and the VPC ID. So on AWS, those appear. There's less need for it on Google, where the objects are referenced by name. But this works well where you put it into a TF module, and then you check it in with your application, and then your other Terraform things can reference your kops managed cluster. How are we doing on time? We're doing good. Yeah, we're doing good. All right. That was a very, very quick, and then so you go in there, you'd TF plan, you'd TF apply, and it would create your cluster for you in that way. So we have raced through the kops user experience, like what it is like to run a cluster using kops. Let's see. So where are we as a project? Like what is happening in kops land? So today we work great on AWS and on GCE. GCE is technically still feature gated, but we're just trying to figure out whether IP aliases, which are a sort of relatively new feature of Kubernetes and Google Cloud, whether IP aliases should be turned on by default or not, because it's sort of hard to switch between them. So that's what's holding up GCE, but there's some excellent work going on right now. Thank you, Andrew, for our DigitalOcean support. Is coming in, what's the state, where would you say it is?
It's still alpha, but
still alpha?
beta soon.
Beta soon, there we are. So DigitalOcean, some people are also, members of the community are also contributing on OpenStack, vSphere, and Bare Metal, and I think Ali Yun Cloud as well. This slide is out of date. I don't know if anyone from those clouds are here, but thank you for your work if so. So, a couple of clouds today, lots more coming. The project as itself is pretty active. There are around 400 contributors, more than 5,000 commits, and more than 5,000 GitHub stars, so lots of stuff happening. Yeah, I say around 400 contributors because we're a little under, so please come and contribute a fix so we can have more than 400 on we can have more than on all of these, but yeah, big project, lots happening. I'm trying to do a sort of race through everything to give everyone a grounding in this, no matter like where you are. Very quickly, how it works. We use the Kubernetes API machinery for the core objects, so the cluster and the instance group objects you saw, and the way like kops edit was able to behave sort of similarly to kubectl edit. That all works because we're using the Kubernetes API machinery. So one of the things that we are hoping will happen, or I'm hoping will happen, and I'm going to work on, is creating a server version of kops. So right now, kops is a CLI tool, but because we're using API machinery objects, we can actually create a kops server and interact with kops in that way. That would mean that right now you can have a team and you can all share an S3 bucket or a GCS bucket. This would be even more advanced, where you can start to apply RBAC rules or namespaces or whatever you can do with Kubernetes, all of those sort of things. So we create those objects, or we manage those objects, or you manage those objects, and then the kops tool, when you run kops update, it maps that. There's a model layer which sort of transforms the objects, cluster and instance group objects, into tasks, which are the units that will go and create a firewall rule or a auto-scaling group on AWS or a managed instance group on GCE. So the model layer is what sort of translates from the abstract, this is the cloud, this is the configuration of the cluster that I want, into actual cloud, the manifestation in cloud objects. So it's the one that knows like what's the right way to run a cluster on AWS, or what's the right way to run a cluster on GCE. And then each task is sort of responsible for reliably creating or updating, changing the cloud objects. So each task has retry logic. Each task has like mutation logic to update it. Can write to Terraform or CloudFormation. That's sort of the structure of it if you ever get into the code. And the tasks, by the way, are when you saw the dry run output, when I ran kops update cluster without yes, and we saw the simulation of what was going to happen, those are the tasks. That's a diff at the task level. So when you're using the CLI, all the CLI is doing is generating those tasks and then essentially running them all in sequence. We have a sort of clever directed tree or directed graph algorithm to sort of figure out the correct sequence in which to run them all. And each task sort of in a Kubernetes-inspired way reconciles the actual state of the cloud object as it finds it to the state which is desired. And so kops creates the instances, those cloud objects, and then it exits the picture. It doesn't run anymore. It's not running on your cluster. And that has some good things and some bad things, one of which is, a good thing is that it can export to Terraform or CloudFormation. So we don't have to do the actual creation ourselves, and we can pass it off to another tool. Another good thing is that it's self-healing. One of my favorite party tricks is to like turn off all the nodes that you have, all the instances that you have, and on AWS, an auto-scaling group will cause them to basically relaunch. The same thing on GCE with the managed instance group. So you don't, at 3 a.m. in the morning, when you have a disaster, you're not running the kops CLI tool again because we're not in the picture anymore. The bad thing is that we probably should, currently we don't even check success. So the kops tool exits like after about 30 seconds, but it takes around 4 or 5 minutes for your cluster to come up. And so if you don't have enough quota, for example, for a machine to launch, it's a little bit awkward to figure out exactly why. So we're going to have to fix that in the UX. But I think we have a kops validate command, so we just need to like spawn that one and then watch what happens. The more interesting, or where things go wrong more, therefore, is how it works on the node. So each instance that boots up, we want to have it join the cluster, either as a master or as a node. So the instance boots up and runs a startup script. On AWS, that's the user data. On GCE, I think it's also called the user data, maybe the instance data. But there's some startup script mechanism which is run at boot. And the role of that script is only to download a component we call NodeUp. And NodeUp's job is essentially to normalize the image. By that, I mean install any packages that are required and missing. So I think we install Git, for example, because technically Git is a requirement of Kubernetes in terms of the Git volume source, get volume. We installed the correct version of Docker for whichever version of Kubernetes you're using. Each version of Kubernetes is tested with 1 or 2 versions of Docker. So we try to make sure it's the right one. We install kubelet, obviously. We install the control plane manifests, and we install a component called Protocube. And Protocube runs on the master, and Protocube's job is to deal with etcd. So Protocube will go and find the correct volumes for etcd, will start etcd and install some other system manifests like kubedns. So this is sort of the Protocube creation of etcd is sort of the big trick, that's how it works when you turn everything off. Protocube is the bit which goes and discovers, oh, I should be a master and I need to run etcd, and I should go and get the relevant volume and mount it, and then act as a particular member of the etcd cluster. Kops uses DNS for discovery. That was sort of one of the big design decisions. Discovery, the 2 sort of main elements of discovery are that each node has to be able to know where the master is. In a cloud-type environment, that's not obvious. And the other one is that the etcd nodes need to be able to discover each other in an HA master scenario, or in a high-availability etcd scenario. That proved pretty good, but if you wanted to use real DNS, it was a bit of a hurdle for some people. So you saw that I created test.k8s.local, which is a new one we have called gossip DNS, which is sort of an easier way to get going. It's not as reliable as a real DNS name, but it is. We do test it. It seems to work fine, but it's just not the preferred option, but it's certainly much easier to get going with. The best option is to use a real DNS name. That requires setting up your NS records, which is the challenge sometimes. On AWS, you can use a private hosted zone in Route 53, which means that it doesn't actually have to be a real DNS name anymore. Anyway, so that you do kops create cluster --DNS equals private, if I recall correctly. But DNS for discovery was a sort of big design decision for kops, and it worked out okay, I think would be how I'd put it. So what is sort of the vision for kops? What are we actually trying to achieve here? Kops is sort of a big thing with a lot of pieces built into it, and I think everyone wants. There's a lot of efforts happening in the Kubernetes installation space, and I think for kops we have a lot of good ideas and some ideas that maybe didn't work as well, and so we want to sort of break up kops into the relevant pieces so that we can share the pieces and reuse pieces that other people have used. So the Protocube component, we're going to break it up into sort of a separate etcd manager, an add-on manager, thinking about the DNS and discovery manager, how discovery works. NodeUp, we want to basically integrate with kubeadm, which does a fairly good job, or does a good job of the equivalent functionality for NodeUp, but we also have some extra pieces we do, like kubeadm does not install Docker, so we need to figure out who's going to do that task. And the other goal is to pull more logic out of NodeUp to make sure that essentially it's just much simpler. Right now, NodeUp does some sort of generation of the API server manifests, for example, and it would be great if that was already done right beforehand, so you knew exactly what you were getting. And then the kops CLI, there's this amazing effort called the Cluster API or the Machines API, which is going to bring machine management into Kubernetes or the Kubernetes API itself. We're going to adopt the Machines API, and by doing that, again, we're going to hopefully make the kops CLI itself just be a very simple, much easier piece. So breaking it all up so that everything is more reusable and easier to understand. etcd manager is sort of the big one. I don't want to spend too long on this, but basically we are working on getting etcd. Most users today of kops are using etcd2. etcd2 is deprecated or will be removed. It is deprecated, and etcd2 will be removed in Kubernetes 1.13. So we have to help our existing users get from etcd2 to etcd3, and we're sort of leading the charge, I guess. We're championing like how we get there, particularly in an HA scenario. And so etcd manager is going to be the piece that does that. So in 1.9, we added backups, which are sort of the first step to move from the Protocube etcd manager to the standalone etcd manager. In kops 1.10, which is not released yet, you'll be able to opt into etcd manager. and we're going to make etcd3 the default for new clusters. And in 1.11, the plan is to make etcd manager the default for new clusters, and you'll sort of opt out. And so the idea being that by 1.13, everyone should be very happy to move to etcd3. Cluster API, Machines API, I don't know if you've seen this, otherwise there are some great talks on this that probably, given our time, we should probably, I recommend catching up on the videos when they're posted, but essentially lets you create a machine object, which is sort of, I think of it like a pod, and it goes and will create, when you create a machine, there's a controller that will go and create a machine, an instance from AWS or from GCE or from DigitalOcean, and that on top of that machine notion are built some generic controllers that should work the same way on every cloud, a machine set, which is like a replica set, and a machine deployment, which is like a deployment. So soon you will be able to manage instances in the same way that today you manage your pods, so through deployments. And each cloud or each provider will only have to write a machine controller, and the machine deployment will work the same way. We're thinking about in kops, like how should discovery work? Is DNS the best mechanism? Can we move? There's a great project called external DNS, which we may be able to use, and other mechanisms for discovery include things like IP tables. So IP tables are the way that services work in Kubernetes, and can we adopt those as a more reliable way or of doing discovery that doesn't require you to go get a real DNS name? And Addon Management, I think, is the last thing that we're sort of looking at splitting out. So kops includes some, I guess you'd call it extras, things that aren't like they aren't absolutely required to be part of Kubernetes itself. We want to find a balance between where we currently are, where we bake them into kops, and it's quite hard to change them, versus a world where you have to like figure everything out yourself. So it's nice, if you think about the UX that we started with, it's nice that it was kops create cluster. I think it's nice. I think it's nice that it was kops create cluster, test.k.local in the zone. I didn't have to specify like a DNS version and a CNI version and a cloud controller manager version and all those things. You can specify network plugins there today, but we want to make that more, we want to make it easy to use while not and predictable, while not necessarily having to bake everything into kops. So that is what Addon Management should be, I think, and that's what we're trying to figure out, how to reconcile those sort of conflicting requirements. I think we have time for Q&A. I've raced through that, I apologize, but shall we do other questions? If there are questions, I think we can just stand up and I will repeat the question or just shout.
So what kind of state do you store in S3 and Google bucket?
Yes. So the question was, what sort of state do we store in the S3 or the Google bucket? So when we do a kops create cluster, we created those API objects and we stored them into S3. And we do that or GCS or other, it's a plugin mechanism. I think DO has support for DO spaces. So we create the core objects themselves, the cluster, the instance group. There are also some secrets that are sort of created and stored in there. We use S3, or we use the state store instead of a real API server because of sort of the chicken and egg bootstrap problem. So you don't have to have a server first, but otherwise, they're real API machinery objects. It would be very natural to put them in there. That's sort of the first class of things that we store. The other one of which, and it's sort of confusing that we put them into the same bucket, is that we also store the rendered configurations that are used by the nodes, for example, when they come up. So we will store like the full kubedns manifest we put in there so that the nodes know what to configure. And that's about pulling as much logic as possible out of node up and into a more predictable way so you can sort of see what's happening. And that will help us to, with the add-ons effort, to make it more predictable and easier to customize. We're working on splitting those two concepts up because they don't logically, it's convenient, but they aren't required to necessarily be the same. They shouldn't be required to be the same bucket.
How do you deal with expiring TLS?
So the question was, how do we deal with expiring TLS? The answer is, well, we can do, so the glib answer is we set a 10-year exploration. The not so glib answer is I think we can now do TLS rotation, but honestly, I think our TLS rotation right now is disruptive. Honestly, we don't yet. I think we're close in that today you can delete a key, create a new one, rebounce your whole cluster. It's not a great solution, but if you have to, that will work. We're getting closer and closer to being able to run multiple certs, and all the machinery is there. I just think we haven't wired it up fully yet. So the answer will be that you will go into kops and do some command to like refresh your certificates or regen your certificates, and it will be able to cope with both. But today we don't yet do that. Yeah.
Do you envision kops being used to manage or to configure and manage Kubernetes clusters on GKE and EKS, and in addition to full self-managed clusters?
Yes. So the question was, do I envisage kops being used to manage clusters on managed solutions such as EKS or GKE? I think that would be great. I think there's some differences in the models used. So when we edited the cluster, there were a lot of options in there, and you don't even see, like, a lot of the options are just omitted if they are default. So it can be tricky to match the full specification into the things that EKS or GKE or Azure's managed service supports. The machines API, I think, is sort of a better approach. So the hope is that when we all manage our machines through machine deployments, that will be kops will use a machine deployment, and kubeadm will use a machine deployment, and EKS will use a machine deployment, and everyone will use a machine deployment. And that might be a sort of kops-like experience without necessarily requiring you to use kops. It's not. So we could maybe do it. I'm not yet convinced. I think I'd certainly accept a PR if someone wanted to work on that. But right now, it's not obvious that the benefit is worth the cost.
Is there any support for day 2 operations besides the auto-scaling group at the infrastructure level, but more like process health management and everything?
You were saying, is it?
Yeah, is there?
So the question was, is day 2 operations, like, is it simple for health management and process management, and what do we do after this? And the answer is that we don't really get as involved in that. It's more about the management of the cluster itself, so the upgrades and lifecycle of the cluster. So a new cluster version or a new kubeDNS version or something like that. That is more what it manages. And I think installing some sort of your management tool of choice is where we sort of hand that off. So we don't really get as involved in that. I'm not sure if that's the right thing to do, but it seems like we try to set it up in a good way, and then it would be nice if some good add-ons were available that set you up well for day 2. But we currently don't really do that. There's one at the back, and then sorry. Okay.
I know that kube versions are tied to kops versions, and I understand why that is. But do you ever see that the delay between kops releases and kube releases getting smaller?
Yes. So the question, which is very politely put, given the given the state of affairs, is essentially currently a kube version and a kops version and a kube recommends or is tied to the kube version, Kubernetes version, and there can be a delay, and that delay can be large, and can we make that shorter effectively? I think, so you'll notice that we haven't released kops 110, which means that Kubernetes 110 is not officially supported. The Kubernetes 110 works with the current master. We EDE test, so it is working. But what we said up to date, up to the beginning of the year, is that we release kops 110 when Kubernetes 110 and all the CNI providers and everything is working and stable, and we would be happy to run it in production. What we discussed in the office hours for kops, which is every other Friday, it's noon Eastern, 9 a.m. Pacific, so please attend, is the idea of moving to a model where we do alpha and beta releases much earlier. So people like the idea that a kops 110 means probably good to go, unlike Kubernetes 110.0 where 1.10.1 is probably quite close behind. But we want to let people choose to run Kubernetes 1.10 with kops 1.10 even before we make that guarantee. That has been held up because of the etc manager work, which has proved tricky. But by 1.11, we're hoping to be alphas released much. Kops 11, 1.11 alpha should be released very early, or sort of missed the boat on that, but much earlier in the cycle. By kops 1.12 alpha should be released very early in the cycle. How about that? And we're working on it. So that's sort of the trade-off, and the earlier release of alphas and betas are how we're trying to address that and give you the choice instead of saying, no, you can't do that.
Yeah, you mentioned a few times about making things more predictable.
Yes.
Your plans in the future. Does that mean that sometimes it's not predictable?
So the question was, that I mentioned a lot about making things more predictable and whether that implies that things are not predictable. I don't believe things are not predictable, but I think there's also the output, for example, which you saw from the kops update, wasn't entirely obvious about what was going to. I didn't think it was entirely obvious about what was going to happen in terms of what exact change were we making to that instance template, right? The Terraform output is clearer and is better, and a lot of the ops people know how to read that output and are familiar with it. So it's about working with the tools that people are familiar with and giving them the better output, but also in a format they can understand. We don't tend to make crazy changes, so any surprising changes should be or are caveated with a big release note, and we're very serious about not breaking compatibility and not making too surprising changes. But I think it's very legitimate for people to want to know the changes that are going to be made, and Terraform seems to be the language that people are most familiar with in terms of understanding those changes. Oh yeah, okay, so I think we're at time, so please come up and talk to me if you have more questions, but otherwise, thank you so much.